like to do a couple of heat capacity calculation examples. A couple of things I want to remind you of. We've got our main equation here of Q heat is equal to MC delta T. Remember, delta T is the final temperature minus the initial temperature, so we would rewrite that as Q is equal to MC TF minus TI, T final minus T initial. A couple of key things about water. C for water is going to be equal to 1 calorie per gram degree centigrade, or 4.184 joules per gram degree centigrade. A couple of key constants there. First, calculate how much heat is required to warm 275 grams of water from 76 degrees Celsius to 87 degrees Celsius. So what we've got is we've got 275 grams of water. That's our mass. Water is our material, so we're either going to use 1 calorie per gram degree Celsius or 4.184 grams per joules per gram degree Celsius. Going from 76 degrees Celsius, so that's going to be my initial temperature from being that key word that tells us it's the initial. So that's T initial to 87 degrees Celsius. So that's going to be our final temperature, T final. So let's go ahead and use that equation to get our heat. Now that Q is equal to MC delta T, or in other words, T final minus T initial. So I'm going to go ahead and start substituting. The mass is 275 grams times C. I get a choice because it doesn't say like how much heat in calories or how much heat in joules. So I'm going to go with calories because it's an easier number to work with. So I'm going to go with 1 calorie per gram degree Celsius. Again, this is this is water. These two values for specific heat are for water. If this were a different material like iron or aluminum or something else, I'd have to look it up, or hopefully it would be given in the problem. T final is 87, so it's 87 minus 76 degrees Celsius. So I'm going to go ahead and grab a calculator and figure this out. So I've got 275 times 1 times, oh, I should probably have subtracted that first. Let's do that. I got 87 minus 76, 11 degrees times 275, hit enter, and we get 3,025 calories. 3,025 calories, because my degrees Celsius on top and on bottom, they cancel. Grams cancel down here. I'm all set. And now as far as sig figs go, when I subtract this, I get 11. That's to the least number of decimal places, ones place. These guys are to the ones place, so that's okay. My least number of sig figs is going to be 2. This is 2 sig figs. Infinite sig figs, because this is exact, and then 3 sig figs here. So 2 sig figs, that would be the 3, and the 0. Problem is, this isn't going to round up. I'm going to need scientific notation to write this. Right now I've only got 1 sig fig. I got to get to 2 sig figs. So I'm going to put a decimal point here, times 10 to the, I move the decimal place 1, 2, 3 places calories. So with my proper number of sig figs, it's 3.0 times 10 to the third calories. Let's go ahead and try another one. We've got a quantity of water that's heated from 25 degrees Celsius to 36.4 degrees Celsius. That's 25.0 and 36.4 degrees Celsius. By absorbing 325 joules of heat, what is the mass of water? Again, I'm starting with my equation of Q is equal to mc delta T. That delta T is going to be T final minus T initial. Joules, 325 joules of heat energy. I don't like that lighting color. Let's do something a little lighter. 325 joules of heat. That tells me right there, that's Q. So that's going to be Q. We want to know the mass of the water. That's my unknown. It's absorbing the heat, so that means that this is going to be positive. I'm putting energy into my system, into my water. So that's going to be a positive 325. I'm going from 25 degrees Celsius to 36.4 degrees Celsius. So this first one is going to be my T initial. This second one is going to be my T final. So I've got everything I need. I can go ahead and start plugging in, substituting. So I've got 325 joules. It's going to be equal to the mass, which we don't know, so we'll leave that as M, times, now in this case, I've got to choose the 4.184 joules per gram degree Celsius because my units need to agree. 4.184 joules. I need joules here to match up with the joules over here. I can't use calories, otherwise my units aren't going to work out. Per gram degree Celsius times T final, which is 36.4 minus 25.0, that's my initial, degrees Celsius. Doing this, I'd probably go ahead and subtract this first, like I didn't do before. So I'm going to get 325. I know it's joules. All my units are going to work out, so I'll put the final units back in at the end, times M times 4.184 times, I've got 36.4, what is that, 11.4? 36.4 minus 25, yeah, 11.4. Okay, so 11.4. As far as my sig figs go, this should be to the 10th place. It is. When I subtract or add, I count the number of decimal places or number places. Here's the 10th place, here's the 10th place, so I need to go to the 10th place here. At this point, I need to solve for M, so I'm going to divide both sides. I'm going to divide both sides by 4.184 and 11.4. So I'm going to divide this side by 4.184 and 11.4. So what I'm going to wind up with is M is equal to 325 divided by 4.184 times 11.4, which is going to be equal to, let's go ahead and do that now, 325 divided by 4.184, hit enter, and then divide that by 11.4, hit enter, and we get 6.81 grams. 6.81 grams, right? Was that the right number of sig figs? 6.813, yeah, because I need 3 sig figs. I've got 3 sig figs here, 3 sig figs here, 4 sig figs here. So there's my mass to the right number of sig figs. Pretty straightforward stuff once you get it set up. The algebra is pretty simple. It's easiest if you identify your unknown and your givens and before you go ahead and attempt to substitute them into the equation.